Welcome dear students, welcome to the third video for this chapter, some basic concepts of chemistry. Today here in this video, we will be learning about scientific notations, about the percentage combinations, about rounding of a number, a little about molecular mass and formula mass. What are these things we will be learning today in this video? So let's begin today's class. Let's begin with the topic scientific notation first, then we will be moving further to the other topics. So now here in chemistry we study atoms and molecules which have very low masses. Like atoms and molecules, they have very low masses and they are present in very large numbers, and we the chemist peoples, we have to deal with these large numbers oftentimes. Means whenever we will be studying chemistry, we will often come along with some large numbers, like suppose this type of numbers, this type of big numbers with so many numbers of zeros. This type, this can be this much big, or they can also be this small, they can be this small. So now these all numbers, when they are written in this way, they seem to be quite absurd and they look quite weird. Means with so many numbers of zeros on the right, or so many numbers on the zeros on the left, and just a single number. So these type of numbers, they are often represented, or they are often written in a common form, where these zeros, they are expressed in terms of powers of 10. And today we are going to learn about it, that how they are expressed in terms of in powers of 10 and what are these terms known as. These numbers are simple numbers that you come across. These are the simple numbers, and when these numbers are expressed in terms of powers of 10, that is known as your scientific notation here. Similarly, this is also a normal number, a decimal number that till now which you have come across. Now we will be learning about the scientific notation of these numbers. So now what is scientific number or the scientific notation of these numbers? So here the scientific notation of these numbers, they are expressing a given number in terms of powers of 10. Now how it is done, I will be telling you here. For a number of this type, here scientific notation is a number where you have to express any given number in terms of decimal, where the number of digits before decimal should be only 1, and these zeros, they are not written after decimal. So now how we have to write? Suppose I am writing a simple number 43, then this contains a decimal, but the decimal is often omitted because after that all are zeros here. So if this one I have to write in terms of scientific notation, then scientific notation says that before the decimal there should be only only one natural number. Before the decimal you should have only one natural number, but here in this case we are looking into two natural numbers. So now you have to express it in such a way that there should be only one natural number. So in that case you have to shift this decimal one digit towards the left side. So now when you are shifting this one digit towards the left, this will become 4.3. Now you have to multiply this one, multiply by powers of 10. Now here you see, in this case, how many digit your decimal is moving? Earlier it was present here, it is moving just a single digit, only 1. So here the power will come 1. Now keep one thing in mind, that whenever you are moving towards the left, your power of 10 will be positive. Let us do another one, 432. And if I am to express this one in terms of scientific notation, then here also my decimal point is here. Now this time I have to move it 2 digits. My decimal should be here. So I will be writing it as 4.32 multiplied by 10 to the power 2. Here also my decimal is moving towards the left. It is moving towards the left. So here my power will be positive. So let's try to express this long one. Now here, how many, where is my decimal? My decimal is present here, where the pure number ends. So now my decimal in scientific notation will have to be moved here, means it should move from there to here. It should come here, because in scientific notation before the decimal you should have only one natural number. it means that you will have 6.02, and after the decimal these all zeros are not written, then multiplied by 10, then now you have to count that your 0 is moving how many places. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. They are moving 17 places here. So now when it is moving 17 places, up to here it was 17 and 18, 19, means it has moved some 19 places here, then only it will reach here. Once again let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Now you see my decimal is placed here. In this case, it means it has moved 19 places. And this case also you are moving towards the left. Now when you are moving towards the left, your power will be positive and it will be 10 to the power 19. So the scientific notation for this large number will be 6.02 into 10 to the power 19, and this is accepted that this is the scientific notation and this is how this type of long numbers are written. Now let's try for this number here. Now here my scientific notation says that before the decimal I should have a natural number, but here I have a 0 which is not a natural number. It means that my decimal should move after 2, it should come here. Then how I am going to write this one? Then my number will be 2.0 multiplied by, now I have to count that how many digits is moving, and here once again powers of 10. Then now let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 digits it's moving. So here 10 to the power 11. But now this time I am moving towards my right side. See, I am moving towards my right side. So in this case my power will be negative. So let's take two pure examples. Let's take some another example here, where suppose I have a number 0.002. I have suppose 2, 3, 5, 6, then 7, 2, 8, 0 and 0.000015. Now I have to express them in terms of scientific notations. Now what are the scientific notations for this numbers? We have to write it now. So let's try to write it. Here it will be 2 only because my decimal should move up to this place. It will be placed here. So now 2 multiplied by how many digits my decimal is moving? 1, 2, 3, 4. It means it will be 10 to the power 4. Now I am moving towards the right side. Towards my right I am moving. So here the power will be negative. In this case my decimal is after the pure number here. Now for the scientific notation I will have to move it to this point. So it will be 2.356 multiplied by, now it is moving 3 places, 1, 2, 3, then it will be 10 to the power 3. I have moved towards the left, so my power will be positive. In this case 7.28 multiplied by, after the decimal the 0 is not written if it is present in the terminal position. Now here it will be 7.28 multiplied by, my decimal was here, I am moving 1, 2 and 3 places. So it will be 7.28 multiplied by 10 to the power 3. I have moved towards the left, then once again there will be no decimal, no negative sign. In this case my decimal will have to come up to after 1. So here it will be 1.5 multiplied by, let's see how many digits, 1, 2, 3, 4, 5 digits. So it will be 10 to the power minus 5. So this is how your scientific notation is expressed. So now after doing the scientific notations, we have to see the rules for rounding off, means how a number is rounded off to the nearest number. For this we have 3 different rules. Now what are those 3 different rules? You see, if the rightmost digit is to be removed is more than 5, the preceding number is increased by 1. It means if the rightmost digit is to be removed, suppose if you have a number 2.356, now it is said that you have to round off to only 2 decimals, means after the decimal there should be only two places, only two numbers should be there, then now you have to round it off. So for rounding it off, if the third number, here the last number is more than 5, so 1 will be added to the previous number. Now this will be 2.36. Similarly, if you have 2.578, then 1 will be added to the previous number and it will be 2.58. This is your first rule. Now the second rule says, if the rightmost digit to be removed is less than 5, the preceding number is not changed. It means that if you have a number, suppose 3.564, and now if you are removing this one, then here the nearest number will be only 3.56, because this third number, the rightmost number, it is less than 5. Then in that case nothing will be added here. Suppose if you have 2.571, then in that case 2.57 only. Now the third rule. The third rule is said that, and this one is very important actually. You see, here it is said, if the rightmost digit to be removed is 5, then the preceding number is not changed if it is an even number, but is increased by 1 if it is an odd number. Now what does this say? See here. It says that if you have a number, suppose 2.345, and another one, suppose 2.39, not 9, suppose let's say 375, then now what will happen in these two cases? It is said that when the rightmost number is 5 and the number preceding that one is even, then it is not changed. Means if you are rounding it off, it will be direct 2.34, but it changes by 1 if it is odd. It means it will be 2.38 in this case, but in this case it will. I'll take another example for you. 3.785 suppose, and one is suppose 3.755. Then here you see the number preceding to 5, that is 8 here. So now the rule says that it will not change if it is an even number, so it will be 3.78 only. But if it is an odd number, as in case here it is 5, so the answer will be 3.76 when you are rounding it to the 2 decimal places. So this is your rules for rounding off. Now we have to learn about the significant figures. Now what are significant figures? Now these significant figures, they actually are for accuracy. There a word is there which is precision, here. Now precision means closeness. It means closeness to a value, or accuracy, how accurate it is. So now there are certain rules for this significant figures. I'll be discussing with you one by one. Let's see. All the non-zero digits are significant in a given figure. Suppose if you are given a number 285, you are asked that how many significant figures are there. So here you have 3 significant figures. Means all the numbers in a non-zero number, means all the numbers which are in a given number, all the non-zero digits, all of them are significant. So here you have 3 significant figures. Similarly, if you are given 0.25, then here you have only 2 significant figures. Why only 2 significant figures? Because the first rule says that all the non-zero numbers in a given figure are significant. So here no zero numbers, 285, so there are 3 significant figures. Here this is a 0, so only 2 and 5 are significant figures. So for the first rule, you have that all the non-zero numbers in a given number is significant. Let's see the another rule. Another one says that the zeros which precede to the first non-zero digit are not significant because they indicate only the position of the decimal point. Suppose if you have a number 0.004, then in this case these zeros are not significant. This figure has only one significant figure, and that is 4. Similarly, if you have 0.0068, suppose, then here also you have only two significant figures. Only two significant figures. So in a given decimal number, those numbers which are telling us about the decimal points, they are not significant. Only those numbers which are non-zero, they will be only significant. Now another rule, the third rule says that all the numbers which have a zero in between, the third rule says that if a number has 0 in between, like you have 2.005, then now in the first case you see you had 0.006, suppose, then here these two zeros, they are not significant. It has only one significant figure, but now this 0 is embedded in between two significant figures, so this will have four significant figures here. This has four significant figures. This has four significant figures. Suppose another example let me take, like suppose 3.007, this one. So in this case you have, once again, suppose it is 1 here, then here you have 5 significant figures. It means that if a 0 is bound in between two significant figures, means in two non-zero numbers, then that 0 becomes significant. But in these cases, this 0 is not significant or it is insignificant. Now another one, like pure numbers, 0 at the end or right of a number are significant provided they are on the right side of a decimal point. For example, if you have suppose a number 0.200, suppose, if this is a number, then this 0 will be significant, but this 0 is not significant. Means the 0 which is before a non-zero number, that is non-significant, but which is after a non-zero number, that becomes significant. So in this case you have three significant figures. Here you have three significant figures, but the first one, it is not calculated. This 0 won't be taken here. Suppose if another number you have, like suppose a pure number 100 you have, then in this case you will have only one significant figure, that is 1. Only one significant figure is present here. Only one significant figure. But if you are given 100.0, then in this case you have 4 significant figures. Means the addition of the decimal sign, it makes it a significant one. This is now all the numbers present here, they are significant. So only 100, it has one significant figure, but 100.0 has 4 significant figures. Similarly, pure numbers like 2, if it is given only 2, then this has uncountable number of significant figures. They have infinite number of significant figure. Infinite number of significant figure. Why? Because 2 can be written as 2.00000000000. In this way you can write it infinite number. So this has infinite number of significant figures in this case. So these are your 4 rules for significant figures. Now another one is, now we will do arithmetic operations of exponential number. Now arithmetic operations, they are 4: plus, minus, multiplication and divide. These 4 operations, they are known as the arithmetic operations. So now we are going to do this arithmetic operations of exponential number. Suppose first of all let us begin with the addition one. Suppose you have 5.6 into 10 to the power 5 plus 5. Suppose 8 into 10 to the power 6. Now we have to add these two numbers. So how this addition will be done? In the addition here, your first aim will be that whatever the exponential number you are given, they should contain the same power. Now here you see, in one case it is 5, another case it is 6. So your aim will be that both of the cases you have to make it similar. Not similar, actually you have to make it same. Either this one you have to make it 6 or this one you have to make it 5. What we primarily accept is or adopt is that we will reduce this one by 1. मतलब बड़े वाले को छोटा बनाएंगे. The 6 we will make it 5. Then how we are going to do this? Let's see. This one, this will be written as it is, 5.6 into 10 to the power 5 plus. Now here you remove 110 from here. It will become 5.8 into 10 into 10 to the power 5. This can be written in this way because 10 to the power 6 means 10 into 10 to the power 5. So now here this one, now you multiply these two. When you are going to multiply these two, you will get 5.6 into 10 to the power 5 plus 58 into 10 to the power 5. This 10 is multiplied by this 5.8, it becomes 58. Now in these two cases you can see that 10 to the power 5 is common. So take 10 to the power 5 common, you will be left with 5.6 plus 58. So now you have to add this and you have to write in your copy, that is your duty. Then suppose after adding this one you are getting some value x and you have to multiply it with 10 to the power 5. And now this is your duty, you have to solve this by tomorrow, by today during the class hours, and you have to send it to me. Means you have to send it to me by 11:30. Before sorry, not 11:30, 12:30. Before 11:30 today you have to send this one to me by solving this, that what is the value of this x. This is your first assignment today, this is your first homework for today. Now another one, this is the first one where we have done the addition. Now similarly for the subtraction also, similarly for the subtraction, here you will have subtraction, here you will have subtraction. Now let's see, if in case of subtraction the number will not change here, I am not changing the number. In case of subtraction also the technique adopted is same, that either this one you have to make it 6 or this one you have to make it 5. So if both of them become same, by the same technique you have to take the common power, means 10, the power of 10 as common, and then whatever you are left with you have to just subtract them. So now 5.6 into 5.8 you will get some minus value, some 5.6 minus 58 you will get some negative value, and that negative value you are to express in terms of this powers of 10. So this is your arithmetic operation, which is the first one. These two we have done for the addition and the subtraction. Now let's see what about the multiplication and what about the division. Now in case of multiplication and division, so for the multiplication and the division we have that's very simple. Here nothing is there. Suppose you have been given 9.8 into 10 to the power minus 8 suppose, and you have been again given multiply. So this is the first value and you are to multiply this one by suppose some 3.7 multiplied by suppose say 10 to the power minus 4 suppose. Now you have to multiply these two numbers. Now how we are to multiply? So in this case we have to multiply the exponential number with the exponential number, means these two numbers will be multiplied together and these two remaining numbers will be multiplied together. So this will be equal to 9.8 into 3.7, 9.8 into 3.7, again further multiplied by 10 to the power minus 8 multiplied by 10 to the power minus 4. Now these two, this again a simple calculation is there that can be done by you. Here how it is done? So these two you multiply, you will get some value of x. Now here the bases are same. When the bases are same, what we do with the power? We just add them. So 10 to the power minus 8 plus minus 4. So now this is again your duty, you have to solve it and you have to send it to me today. Similarly for the case of division, for the case of division also it is of the same type. I will show you how it is done. For division, suppose you have suppose 3.0 into 10 to the power 8 suppose, divided by suppose it's 1.5 multiplied by 10 to the power say some 16. Now you have to divide these two values. Now when you have to divide these two values, you have to do again the same thing, means the number which is a pure number, that one you have to divide together, and the another one that will be divided together. So 3 into 1.5 multiplied by 10 to the power 16. So these two you have to divide together. Now this is a very simple one. 1.5 2 times is 3, that is equal to 2 into this 10 to the power 8 and minus 16. This will be equal to 2 into 10 to the power minus 8. So this one also you copy it down in your copy and have to send it to me. Now how? Let's move to the another one. Now what is the another one? The last topic, I think the last one, it is the percentage combination. Now what is percentage combination? So percentage combination is defined as the mass percent of an element, which is defined as mass of that element which is present in a compound multiplied by 100 by the molar mass of the compound. Now before that we have to know that what is molar mass or molecular mass. Molar mass or molecular mass. Molar mass or molecular mass both are the same term. Molecular mass, they are the same terms here. Now what is molar mass and what is molecular mass? We all know about atomic mass. Whenever the mass is calculated for an atom, that is known as its atomic mass. Suppose the mass of carbon is 12, the mass of chlorine is 35.5, and the mass of water H2O, that is 18. So now in these cases you see we have a element only an element is there, but here what is there? Elements have combined and they have formed a molecule. So the mass of a molecule is known as its molecular mass or molar mass. So now how to calculate the mass percentage of an element in a compound, I'll be showing it to you. Here one question is given. Now what is the question? The question is say that what is the percentage of carbon, hydrogen and oxygen in ethanol? Now for ethanol, first of all you need to know that what is ethanol. So ethanol has a formula CH3 CH2 OH. So now here you have to calculate that what is the percentage of carbon and hydrogen and oxygen in ethanol. You can see that here how many atoms of carbon are there? 2 atoms of carbon are there, 6 atoms of hydrogens are there, and 1 atom of oxygen is there. So now we have to find out the percentage. What is the percentage? Now how this percentage is calculated? So the formula given was that mass percent is given as mass of that element in the compound by molar mass of the compound. It means that first of all we will have to determine the molar mass of the compound. Molar mass of the compound here. So molar mass of the compound will be the atomic mass of all the elements which are present in ethanol. Now what are the atoms which are present in ethanol? Let's see that one. Now here in ethanol I have 2 carbons. So 1 carbon is 12. So 2 carbon will be 12 into 2 plus 1 hydrogen is 1. So total how many hydrogens are there? 6 hydrogens. So it will be 1 into 6 plus how many oxygens? Only 1. So atomic weight of oxygen is 16. So now we have to add this 24 plus 6 and plus 16. So now this becomes 24 plus 6 is 30 and 30 plus 16 is 46. It means that this is the molar mass. The molar mass of ethanol is 46. Now we have to calculate the percentage of carbon. So the percentage of carbon is given by what is said, the formula is said that mass of that element in the compound by molar mass of the compound. So now we have to see that what is the mass of our carbon in the compound. So the mass of carbon is 12 into 2. Similarly, the mass of hydrogen is 1 into 6 and the mass of oxygen is 16. So now for carbon, so the mass percentage of carbon will be equal to, what does the formula says? The formula says mass of that element in the compound. So mass of the element carbon is 24 by the molar mass, that is 46, and you have to multiply this one by 100. So once again your duty is you have to find out the molar percentage, that will be suppose say some x percentage. Similarly, the mass percentage of hydrogen you have to calculate, and that will be 6 by 46 multiplied by 100. So you will get some y percent again here. Then again mass percentage of oxygen this time. So oxygen will be 16 by 46 and multiplied by 100. Suppose say you will get some z percentage. So now this value of x, y and z you have to determine, and you have to send it to me today during the class hours, that is before 12:30 p.m. You have to send this one to me. Now these were the percentage of carbon. Now let us see one more last topic, and that is your mole concept. Mole mole concept. I'll be making a separate video for this mole in the next class, but at present here let's conclude this one with our mole concept. Now what is the mole concept? Here in the mole concept we will be told about that what is a mole. So 1 mole of any substance, 1 mole of any substance, it is defined as the amount of substance which contains as many particle or entity as there are atoms in exactly 12 gram of the C12 isotope. It means that here suppose what I say that 1 dozen of anything, 1 dozen of anything is equal to 12. 1 dozen of anything is equal to 12, whether it may be eggs or it may be banana or it may be anything. If I am saying 1 dozen, then the shopkeeper or the person whom you are asking for, like if you are asking someone for 1 dozen of banana, then he will definitely give you 12 bananas. If you are asking for eggs, he will give you 12 eggs. He will not differentiate that whether this is egg or whether this is banana. Similarly, for the ease of our chemistry, this mole concept was drawn, and this mole concept says that 1 mole of any substance, 1 mole of any substance in gram, that is always equal to its molar mass. So if I am saying that 1 mole of carbon, then that will be equal to 12 gram. If I am saying 1 mole of oxygen, then that will be equal to 16 grams. If I am saying 1 mole of hydrogen, then that will be equal to 1 gram. So this is your mole concept here. Now this one we are talking in terms of pure elements only. These are only elements. Now when we talk about molecules, like 1 mole of water, 1 mole of water. So what is the molecular weight of water? So that is 18. So 1 mole of water will be equal to 18 gram. Similarly, 1 mole of NaCl, 1 mole of NaCl, that will be equal to sodium. What is the atomic weight of sodium? That is 23, plus chlorine it is 35.5. So here it will be some 0.5, 5 plus 3 is 8 and 3 plus 2 is 5, 58.5 gram. So 1 mole of any substance in gram is always equal to its molar mass. Now here comes the important Avogadro's number. Now what is Avogadro's number? Avogadro's number says that 1 mole of any substance will always contain the same number of particles, and that particle is equal to 6.022 into 10 to the power 23 here. Here 1 mole of any substance will always contain this many number of particles. Now if you are taking 1 mole of carbon, that will also contain this many number of atoms. If you are taking 1 mole of oxygen, that will also contain this many number of atoms. If you are taking 1 mole of hydrogen, that will also contain 6.022 into 10 to the power 23 number of atoms. So this was related to your dozen, like 1 dozen of anything will be 12. Similarly, 1 mole of any substance, that will be always equal to Avogadro's number, and that is always equal to the molar mass of that particular substance, molar mass or molecular mass. This is your mole concept here. So now I'll be uploading the notes for this also today in your Campus Care app. You kindly download it and write it in your copies. The copies that can be used by you can be of any type, whether it may be plain or ruled. But what will be preferred is, what I will suggest you is that use plain copies for chemistry. That will be better for you. Okay. So with this, I end the class here. Thank you for watching the video up to here. Thank you very much, and have a good day.